All right, geometry 12.1 and 12.2. We're talking about 3D figures and surface area. This first section we're just gonna kind of briefly gloss through, and then we'll look at 12.2 a little more in depth. So we're going to use isometric dot paper to sketch a triangular prism 3 units high with two sides of the base that are 2 units long and 4 units long. Okay, so first we'd draw a corner, and then we can go 3 down or 3 up, whichever way you want to draw it, but I would go 3 down from the corner. Okay, and then we can go 2 to the left, and notice here on this paper, when you're going to the left, you're going diagonally on isometric dot paper. So diagonally 2 to the left, we don't go horizontally like this. And then when we go to the right, we go diagonally 4 to the right. And then you can connect those two to form that triangle. And then finally, we draw 3 down and connect those right here and fill in the rest of the shape. So that's what that looks like. Okay, if we want to use isometric dot paper to draw or sketch a solid. So here we have the orthographic drawing. Shows us a top view, shows us a left view, front view, and right view. So in this case, the front view, that's what we have right here. That's the front. Okay, so we could draw these two going down this way, and these 3 going up, over, down, and over. And then we know that from the right view, at the bottom, we go over 2. And then we already know that looking at it this way is 3 high. And then from the left view, we know that that side is just a solid 2 by 2. So the top of the left we have right here. And then from top, what we can see here shaded in, that's the top view. That's how we know that these are different levels. Okay. If we take a shape like a square-based pyramid, okay, underneath there's a square like that, and we cut it horizontally, we would get a square. If we cut it at an angle, this angle would go up, and up here, this is a lot shorter than this one down here. So we're going to get a trapezoid. And then if we cut through it vertically, we're going to end up with a triangle. So try to imagine those slices. If you take some cutting device to it here and just slice through it. Alright, so that was all for lesson 12.1. We are now in lesson 12.2. We're looking at lateral areas and surface area. So the lateral area is just this part around the outside. The bases are 2 parallel faces. So here and here, or in this case, we have a base there and a base there. They are in parallel planes. The lateral area, again, goes around the outside. Okay, so there are a few terms here. We know the bases. Everything going around the outside, every flat surface there is called a lateral face. And then every edge is a lateral edge here, and any edge along the base is called a base edge. And if we have a right angle going from the base, connecting another vertex of the other base, it's called a right prism. If that's not a right angle here, then we call that an oblique prism. Okay, to find the surface area of a prism, we would take the lateral, so around the outside, all of these surfaces, 1, 2, 3, 4, 5, and then we add the 2 bases, the top base and the bottom base. So lateral area plus the 2 bases. Now to find the lateral area, I can either calculate the area of each one of the surfaces, or another way to do that is I take the perimeter of the base, so capital B stands for perimeter of the base, times the height of the prism. perimeter of the base times the height of the prism. That gets me the lateral area. Okay, so if I want to find the surface area here, there's several ways to do that. One of those ways is take the perimeter of the base, so 9 plus 4 plus 9 plus 4 times the height is 6, and then times 2 times the base. Now, what's the base? Is the base 9? Is the base 4? Notice this is a capital B. Capital means that it is a combination of lengths already. That's the area of the base. So that's 9 times 4. So 2 times 9 times 4 gives me 36. Simplify those and you get a total surface area of 228 square feet. Okay, if we want to look at a cylinder, surface area of a cylinder here, the axis would be considered the height of a right cylinder. Okay, we also call that the altitude. And since this is a right angle between the radius of the base and the altitude between the two centers of the bases, this is a right cylinder. Since this angle is not a right angle, then the axis is not at a right angle to the radius, so this is an oblique cylinder. Alright, same thing here. I would find the perimeter of the base and multiply that by the height. Now the base is a circle, so the perimeter around the outside of a circle is called the circumference. So we would find the circumference by doing 2 pi r, or 2 times the pi times the diameter. So 2 pi r gives us this length, and then the height of the cylinder is base and width of the rectangle. So if we multiply those two, 2 pi r times the height, then we get the lateral area. So the lateral area is 2 pi r h. And then the total surface area, again, is the lateral area around the outside plus the two bases. Now in this case, the base, the area of a base, is pi r squared. So once we've simplified that or made it specific for a circle, we get 2 pi r h plus 2 pi r squared for the surface area of a circle. Sorry, not a circle. Did I say circle? Of a cylinder. Okay, so here we have the diameter is 15, and we know the height of this cylinder is 18. Pi dh, which is the same as 2 pi rh, because 2 times the radius gives us the height. So we could either figure out gives us the height. No, 2 times the radius gives us the diameter, and then times the height. So diameter 15 times the height 18, and then to find the area of the circle, 2 pi r times the radius squared. We're going to have to find the radius anyways there. Simplify that, and we get a total surface area of 1,201.66 millimeters squared. And that is all the fun we're going to have today.